Usually, straight-chain alkanes are named by adding the suffix ane, as we know, to the prefix representing the number of carbon atoms. For example, we have CH4, which is methane. We have one carbon atom, which is mate, and then we add ane, making it a methane. We can also have C3H8, which is propane. So we have 3 carbon atoms, which has the prefix prop, and then we have ane, that's propane. If I have C4H10, what should this molecule or what should this organic compound be? That is butane. We know that 4 is both. So if I add ane, that gives me butane. So as simple as it goes. So what about this C8H18? Alright, so what compound is this? Try out, ta-da! This is octane. Good. Alright, so this is simply how we can name the alkanes. So although we have a number of rules we have to follow while naming alkane groups. For instance, let's just quickly look at some of these rules, and then we'll have 1 or 2 examples, and then we'll move to the next. Alright, so the longest straight chain in the compound assumes the parent name, while the branch is referred to as alkyl substituents. So if I have and I have CH3, I have CH3, I have CH3. Now, how do I start counting this? So basically, if I start from here and say 1, 2, 3, 4, 5, 6, 7, 8, I'll simply have 8 carbons. But what if I go back and count from here? I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll have 10 carbons. So the right way to count is to count from here and not from here, because I want to count in a way I'll have the longest straight chain to have the name. Alright, so next, the position of the alkyl substituent is indicated with a number. The parent chain is numbered from either of 2 ends, such that the carbon that bears the branch has the lowest possible number. Alright, so let's still look at an instance again. And this is looking almost similar to the initial diagram, but let's see. I have CH3, and I have this, and I have this. So this is CH3, this is CH3, this is CH3, this is okay. So if I want to count from here, I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alright. But if I want to count from over here, I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'll have 11 carbon atoms here, whereas over here I'll simply have 10. Alright, so but if I look at this, if I should count from this end, I'll have the methyl group or the alkyl group at the third carbon here. But if I should count from this other end, I'll have my first alkyl group at the second carbon here. So the right way to count is from here, so that I will have my alkyl substituent indicated with the lowest possible number. So I'll have 1, my alkyl at 2, my alkyl at 3, then 4, 5, 6, 7, 8, 9, 10, 11. So what's 11 again? 11 carbon alkane. An 11 carbon alkane is an undecane, and I have methyl at 2, methyl at 3, and methyl at 9. So I have 2, 3, 9, trimethyl, undecane. Wow. So you see how simple it looks like to actually name these compounds. This is very much interesting. So, but if I had named from this point, if I had named 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, this would have been 3, 9, 10 trimethyl undecane, which is wrong. So this is the right way to name, because I want my alkyl substituents to have the lowest possible number. Alright, so if you got this, I'll go ahead and wipe this off, and then we'll look at the next rule. Alright, so the next rule is the name of the substituent is attached as a prefix to that of the parent chain to form a word. For instance, the previous element we just did, the previous substituent. So for instance, the previous compound we just considered here, we have the parent name undecane attached to this, attached to the prefix. So for instance, using this same example, we can see the substituent, the name of the substituent, trimethyl, is attached as a prefix to the main parent chain name. So we have trimethyl undecane. So this is serving as a prefix to the undecane. So the next rule there, I'll go ahead and check the next rule. So the next rule here says numbers which indicate positions of substances are separated from the name of the substituent with hyphens. So this is what we mean actually. So this is 239. So I'll add a hyphen here, trimethyl undecane. So this number should be separated from the name of the substituents using a hyphen. So names of substituents are separated. So names of, okay, the next rule there is names of substituents are arranged alphabetically with a number for each substituent to indicate the point of attachment for molecules with different branches. Names of substituents always come before the name of the parent chain. So like you can see from our example, you've seen the names of the substituents. Actually, the substituents are still the same: methyl, methyl, methyl. So we have 239 trimethyl. So this 239 is indicating the positions of the methyl. So we have methyl at position 2, we have methyl at position 3, we have methyl at position 9, all separated with a comma, 239. Then you have your hyphen separating the numbers from the name here. So you have 239 trimethyl undecane. So if actually I had substituents with different name, I'll have to arrange these substituents alphabetically while naming. So for instance, let's say I have bromine here. It means the name of this compound will have to change. So I'll have 9 bromo, two, 3 dimethyl undecane. So this is the correct name for this compound. So I'll have 9 bromo, 2, 3 dimethyl undecane. So for the next rule, if a specific substituent occurs as a branch more than once in a compound, the reoccurrence is indicated with the Greek prefixes di, tri, tetra, penta, hexa, hepta, octa, nona, and the rest. So, for instance, in our previous example here, we have 2, 3 dimethyl. So it occurred 2 times at the carbon 2 and at the carbon 3. So we have methyl at the carbon 2, we have methyl at the carbon 3. So making it 2, 3 dimethyl on the cane. So lastly, the last row here, the numbers of the carbon atoms to which a recurrent substituent is bonded to are indicated and then separated from each other by commas. So just like we have in this example here, you have the numbers to which this is occurring. It's occurring at number 2, carbon number 2 and carbon 3 here. So the numbers are listed after each other and then separated with a comma. So we have 2, 3 and then dimethyl on the cane. So next we'll consider the IUPAC rules for naming alkenes and alkynes. Alright guys, that's the end for the IUPAC rules for naming alkanes. So next we'll consider the IUPAC rules for naming alkenes and alkynes.